Today we are going to cover section 7.1, Systems of Equations. So take the time to write down your title, your essential question, how do you use systems of equations to solve complex problems? Go ahead and paste your cutout and we'll start once you are ready. So solutions of systems of equations. A system of linear equations can have one solution, no solutions, or infinitely many solutions. So if you are given two linear equations, so this is an equation of a line, that's an equation of a line, and once you solve it, if you end up with a point of intersection, that means that the lines are going to cross at that specific point. So therefore we have one solution, and therefore our system is consistent. It's very similar to what we cover when we solve equations on chapter 1. So therefore we can have one solution, so that means that they intersect at exactly one point. If when you solve it, you end up, your x's cancel, your y's cancel as well, then you end up with a true or false statement. In this case, 0 is not equal to -9, so therefore it's a false statement, which means that there's no solution, which means that the lines are parallel, and if you graph them, you'll see they have the same slope, but they have this different y-intercepts. So that's something that you want to be able to keep in mind, is that whenever you have two lines, if you find the slope and they happen to be the same slope, but the y-intercept is different, UB, then the lines will be parallel, which means that the system is inconsistent since there is no solution. If your x's and y's cancel, and also your number, or you end up with a equivalent, so therefore they represent the same line, which means that there's an infinite number of solutions or infinitely many solutions, and your system is consistent, and that means that all the points on the line are solutions, so you have an infinite number of solutions. And remember that whenever only one cancels, your x's or your y's, in this case your y's, they do end up with one solution. But let's go and start example number 1. Go and copy it down, go and pause it, and we'll start once you're ready. So solve the system by substitution. So back in Algebra 1, you cover solving systems by substitution and by combination. So by substitution, you need to be able to decide which variable do you want to solve for. And you can decide, you can choose this x, this y, this x, or this y. So let's go and solve for, which will be easiest? Correct, let's go and solve for this y. So I'm going to solve for y. So therefore I'm going to write down that equation. I'm just going to move the x to the right, becomes a positive x. And now that I have the value of y, what am I going to do? I'm going to substitute. And I'm going to plug in the value of y into the other equation. So go through the process, go and pause it, find the value, substitute the value of y, and then see if you can find your solution. And then we can check your answers. Go and pause it. Excellent. So in this case, I'm just going to replace the y. So therefore I have 3x plus 2 instead of the y. I'm going to replace it with x plus 3. From there, we just have a simple equation that we can solve, distributive property. So I have 3x plus 2x plus 6 equal to 11. Combine like terms, 5x plus 6 equal to 11. Move the 6 to the right, becomes a negative. So therefore 5x equal to 1 to 5 and x equal to 1. I found my x value. Now remember that we have two lines, and your solution will be your intersection, which will represent a point. Your x value is 1, so now I need to find the y. To find the y, I can plug in the 1 into this x, but it'll be easier to plug it into here, correct? So therefore, that will give me y equals 1 plus 3. 1 plus 3, which will be 4. And now if I want to check my answer, let me just fix this. If I want to confirm that this is my intersection, that this is my solution, then I can do it two ways. I can graph it, but for today I need to go to check my solution algebraically. So let's go and check. So we're going to plug in x and y into the first equation, should give me a true statement. I'm going to plug it into the second equation and it should give me a true statement. So therefore this solution should be a solution for both lines, for both equations. So let's check the first one. To check it's a very quick process. So it gives me 3 plus 8 equal to 11. So therefore 11 equal to 11. That is correct. Second one, negative x plus y equal to 3. Where the x is 1, the y is 4. So therefore I have negative 1 plus 4 equal to 3. So therefore 3 equal to 3, which is also correct. So therefore we checked algebraically. Now we can also check it graphically. So therefore if I go into Desmos, or you can also use your graphing calculator. Now the one nice thing about Desmos is that you can actually type in the equations as they are. You don't need to solve for y. Where if you're going to use a graphing calculator, then you have to solve for y in order to be able to type in the equation. Desmos has made it much easier to be able to type in equations in standard form. That's the first equation, negative x plus y equal to 3. And therefore, if I want to be able to confirm that that's the solution, that will be the intersection. Example number 2. Go and copy it down, and we'll start once you are ready. Go and pause it. So solve the system by combination, and then I need to check my solution. So one of the things that I noticed is that I have fractions on the second equation. And just like we talked about before, it is best to get rid of the fractions right away. So therefore, what is the lowest common multiple between 3 and 2? Lowest common multiple is 6. So therefore, I'll multiply each term by 6. Basically, multiply the left-hand side and the right-hand side by 6. 6 times x is 6x, divided by 3 gives me 2x, or you can think about reducing it. I can reduce it, gives me 3, or 6 times y is y, divided by 2 gives me 3. My other equation, we have 4x plus 6y equal to 1. And now I'm going to solve it by combination. Now, if you want to solve it by substitution, you still get the same answer. But then it might get a little messy just because once you solve for x or for y, you're going to end up with fractions. So I know that most of the time we prefer to do it by combination, correct? So therefore you need to decide, do you want to cancel your x's or your y's? So let's go and cancel the x's. In order to cancel the x's, I need to multiply that first equation by, or the 2x by negative 2. Because in order for them to cancel, they need to have different signs, but the same number. Second equation will stay exactly the same. Therefore, my x's cancel, my y's cancel. There's nothing left on the left, so therefore we have a 0. And on the right, we have negative 23. So therefore, you need to ask yourself, is that a true statement or is that a false statement? That is false, which means that there is no solution. That means that the lines are parallel. That means that your system is inconsistent. Make sure that if you have no solution or any number of solutions, you tell me whether the lines are parallel or the lines are identical. Now, if I take the time to be able to graph it on Desmos, then I'm going to type in the first equation, 4x plus 6y equal to 1. The second equation will be x over 3. move to the right, plus y over 2, move to the right, equals 2. And notice that whenever they have the same, so let's go to a little more challenging problems. So go and copy it down, and we'll start once you are ready. Go and pause it. So now for example number 3, we have two equations once again. But if you notice, now we have a quadratic equation and a linear equation. Where before we used to have either one solution, no solution, or infinitely many solutions, since we had two lines. So in this case, if we have a parabola and we have a line, how many solutions can we have? Can we have 0 solutions? Can we have one solution? Can we have two solutions? Can we have 3 solutions? So what do you think? So let's see. In this case, we have a parabola. So let's assume that it faces up. In this case, the parabola should be facing up. And move the x to the right becomes a negative divided by 3. So it goes to have a negative slope. So therefore, can it have two solutions? Yes. So if we have a straight line, we know that it's going to cross at least, it can cross in 2 spots, right? We can have 2 solutions. Can we have one solution? So if you have a parabola and a line, can we have one solution? Yeah, I can just cross somewhere. So let's assume it's going to cross here. So it barely just touches it. Can we have no solutions? Yeah, if we just have a parabola, then your line can just be somewhere along here. So therefore we have 2 solutions, we have one solution, we have 0 solutions. Can we have 3 solutions? That is the question. No. Right? Now, how do you solve? So the question is, do you guys want to solve it by combination or by substitution? You get to choose. So if you do it by combination, then you want to cancel your x's or your y's. In this case, we want to cancel your y's. If you do it by substitution, then we can solve for x and then plug it back in. Substitution or combination? Perfect. So let's do it by substitution. And then I'll work it out by combination as well. So in this case, let's go and solve for x. So let's go and x will be, so let's go and just solve for x. So move the 3y to the right becomes say negative 3y minus 4. So we solved for x. And now what should we do? We should plug this into the other equation. So we're going to substitute. We're going to substitute into the other equation. So therefore it will be 3x squared minus 2y equals 5. But instead of the x, I'm going to replace it with the value, which is negative 3y minus 4. So now go ahead and simplify it, solve it, and see what you get. See how far you can get on this problem. So let's see, if I multiply negative 3y minus 4, ideally you should be able to do it without rewriting it. So let's see, negative 3y minus 4 and negative 3y will be negative 3y times negative 3y will be positive 9y squared. Negative 3y times negative 4 will be positive 12, and another positive 12 will be positive 24y. And negative 4 times negative 4 becomes a positive 16. Minus 2y equals 5. And now we just have an equation that we need to solve. We're going to have a quadratic equation. So that gives me 27y squared plus 72y plus 48 minus 2y equals 5. Combine like terms. So I'll combine my y's. And I'm going to bring my 5 to the left becomes a negative. So therefore that becomes 27y squared plus 70y plus 43 minus 5. And now that I have a equal to 0, I can see if I can take out a common factor. Well, 43 is a prime number. Yes. So therefore I cannot divide 43 times 1. Nothing to factor out. So let's go use double parentheses to factor this out. Factors of 27, y squared could be 9 times 3, 27 times 1, 43. If you notice, 27 plus 43 is 70. So that should help us out. So it'll be 27y in y. I'm going to place my 43 in here and my 1. And they both should be positives. Do you agree? So 27y squared, 27y, and 43 will be 70y plus 43. And now we can use the zero product property. So 27, because they're multiplying and they equal to 0, either 27y plus 43 equals to 0 or y plus 1 equal to 0. So therefore, y equals negative 43 over 27 and y equals to negative 1. Now we need to be able to find the corresponding x values. So let's go and plug in the x. I'm going to get this equation here. And now we can just plug it in. So therefore have x equal to negative 3, y minus 4, x equal to negative 3, y minus 4. This one will get negative 1, this one will get a 43 over 27. So therefore x equal to negative 1. Simplify this and see what you get. And then we can check your answers. We can reduce the 3, you got it, pause it. So that's it. We can reduce, that cancels, I guess me 9. So therefore x equals negative is going to be a positive, will be 43 over 9 minus 4. I need it over 9, so I'll convert this as 9. So it'll be 36 over 9. Do you agree? That's negative 4. So therefore that gives me 7 over 9. 7 over 9. So therefore my first solution, my x value will be 7 over 9. The y corresponding y value is negative 43 over 27. Cannot be reduced since 43 is a prime number. My second solution, your x value is negative 1. Your y value is negative 1. And now comes the fun part. Let's go and check algebraically. And the question is, do I need to check your answer? If it says to check your answer algebraically, then it should. But in this case, it does. So let's go and do it. Checking is just a very quick process. Let's go 2 or 3, if I write it down correctly, might help. Minus 2y equals to 5. So let me check the second one, negative 1, negative 1. Negative 1 squared is 1 times 3 is 3. Negative negative positive 2 equal to 5. So therefore 5 equal to 5. Perfect. Now let's try the second one. Let me leave a little more space for the second one. So your x value is 7 over 9. Your y value is negative 43 over 27. So that gives you 3 times 49 over 81 plus 84, 86 over 27 equal to 5. I'm going to reduce my 3 and my 81 divisible by 3, so therefore that's 27. So it gives you 49 over 27 plus 36 over 27. Is that equal to 5? So that is the question. So something's wrong. Why did I mess up something? 86. So this is an 86. There you go. Now it seems like it might be okay. So 120 plus 15, 135 divided by 27 equal to 5. Let me multiply 27 times 5 to see if that's correct. That's 35. Carry 3. That's 10, 13. So perfect. So 5 equal to 5. So you are expected to work through fractions and add them manually. But let's go and check it or multiply them, subtract them, common denominator in the whole process. Let me go through the process and let's just check your answers and see if that's correct. So therefore 3x squared minus 2y equals to 5. And the second one is x plus 3y equal to 4, negative 4. So therefore, those are my two answers. Now, if I want to double check that this is correct, Desmos does a really good job. I can just plot the point, 7 over 9, comma, negative 43 divided 27. And if I type that incorrectly, that might be helpful. Comma. Or you can evaluate your fraction and just confirm that that is correct. And then I can type in the other fraction and confirm that that matches. So that's one way of doing it. Another way is just to count x and y, plug in the point. And that means that that is the correct solution. And you can do the same thing with the second point, which is negative 1, negative 1. Whichever way you prefer to do it. If you need to do it algebraically, some of your homework problems will ask you to do it algebraically. Some of them will ask you to do it graphically. And you just need to be able to make a very quick sketch on your homework of this graph. Or you can also use your graphing calculator if you prefer. So those are your correct answers, and we double checked that they were correct. We checked it algebraically and also graphically. Example number 4. So let's see. Do you remember? Go and copy it down, pause it, and then we can talk about how many solutions we can have. Go and pause it. So let's see. Do you remember what type of equation is the first one? Yes, the first one is a circle. The second one is a line. In this case, move the x to the right becomes a negative, divided by negative is going to be a positive slope. So how many solutions can we have? Can we have one solution? Can we have 0 solution? Can we have 2? Can we have 3? Correct. We can have 0 solutions. Well, let's start with 2 since we started before. We can have 0 solutions. Let's see. 2 solutions. If we cross this here and here, correct? You can have 1 solution. If it barely touches it somewhere, that'll be 1 solution. And it can have 0 solution if it just misses it altogether. So you have 3 options: 2 solutions, 1 solution, or no solution. So therefore, do you want to solve it by substitution or combination? Now, if you want to solve it by combination, you can cancel your x's and y's. I mean, you can square both sides, but then once you square both sides, we know that we end up with extraneous solutions. So you probably don't want to do that. So therefore, by substitution. So go and pause it, solve our substitution, see what your answers are, what your intersections, and then we can check our answers. And pause it. Excellent. So I'm going to solve for x or for y. I'm going to solve for x. I'm going to write down my second equation, x equals y plus 2. And now I'm going to substitute into the second equation, onto the first equation. So instead of the x, I'm going to replace it with y plus 2. Y plus 2 squared gives me y squared. 2y and 2y will be positive 4y plus 4 plus y squared equal to 4. So therefore I have 2y squared plus 4y. Move the 4 to the left becomes a negative, so equal to 0. So they cancel out. I don't need to write the plus 0. Correct? So once I move this to the left, combine like terms. And now how do I solve this? I know that I have a quadratic equation, so I should factor. I need to take out a common factor, so therefore I'm going to factor a 2 and a y. And what's left behind? 2y times y, 2y times 2 equal to 0, so therefore I can use my zero product property. Since they're multiplying and they equal to 0, either 2y equal to 0 or y plus 2 equal to 0, so therefore the y equal to 0, y equal to negative 2. And now that I have the y value, I need to find the x value, so I'm going to plug it back over here. So we have x equal y plus 2, where my y value is 0. So therefore, x equal to, I have x equals y plus 2, and instead of the y value ds, you're going to plug in a negative 2. Therefore, x equal to 0. So therefore, my solution, my x value is 2, my y value is 0, my x value is 0, my y value is negative 2. So those two will be your solutions. And those should be the intersections. So we need to be able to check it both algebraically and graphically. So let's go and check. So go and check it, pause it, and then we can continue once you're ready. To check it, I'm just going to plug it into the first equation. It will be x squared plus y squared equal to 4. So instead of the x will be 2, instead of the y will be 0. So that cancels, so it gives me 4 equal to 4. Perfect. Now I plug into the second equation, so I have x minus y equal to 2. Instead of the x, I'm going to plug in 0. Instead of the y will be a negative 2. 0, that gives me positive 2 equal to positive 2. Perfect. Now, if I take the time to graph it, let's go ahead and clear up everything I have in here. You can also use a graphing calculator. Your graphing calculators also have a way to be able to type in circles, but otherwise you're going to have to solve for y equals. But for now, I'm just going to do x squared plus y squared equal to 4, and x minus y equal to 2. So therefore, my solution are the intersections, which matches my answers. Example number 5. Go and copy it down, and then we can solve it. Go and pause it. Solve the system, then check your solution. So in this case, I need to decide whether you want to do it by combination or by substitution. So in this case, yes. In this case, y equals, so therefore I'm just going to do it by substitution. It's already solved for y, so I'm going to plug it in here. So therefore I'm going to substitute. And instead of y, I'm going to replace it with ln of x. And now I need to solve it. So how do we solve this? So one way is to be able to get rid of the ln, correct? So let's go and move the x to the right. ln of x equals negative x plus 1. Then how do I get rid of the natural log? To get rid of the natural log, I'm going to do the base, correct? So that cancels out. So therefore, x equals e to the negative x plus 1. But now the x is the exponent. Now if I get rid of the base e by doing the ln, I go back over here. So I hate to break it to you guys, but we don't have the tools to be able to solve this equation. So therefore, if I want to be able to solve it algebraically, it might not be possible, but let's graph it and solve it graphically instead. And if you solve it graphically, you just need to be able to kind of sketch a quick graph. So y equals to ln of x, and on your homework you'll have to just, there'll be some problems that they'll ask you to solve it graphically. You won't have to guess which one works. So therefore my solution is my intersection, so my solution is 1, 0. This is my intersection, which is, was it 1, 0, 0, 1? 1, 0. Now to check it, since we did it graphically, we don't have to check it algebraically. So let's just do a quick graph. So 2, 4, 5, 2, 4, 5. We, at this point, we do know what the graph looks like. We graphed that last time, correct? And it's also there. It's a natural log base e, and we know it's going to cross through here. We will make a table, so we graph color something like this. Of course, at 2.7, we can say it's 1. So I missed a little higher, but it's fine. In this case, solve, move the x to the right becomes a negative, so that's positive 1 and a negative slope. So therefore, arrows on both sides, my intersection is my solution. So now let's go through some applications. Example number 6. Go and write it down, and we'll start once you are ready. Go and pause it. So a total of 12,000 is invested in 2 funds. One of them is paying 5% interest, and the other one is 3% simple interest. And if you remember, we talked about interest. We talked about simple interest briefly, and we also talked about compound interest. Do you remember your formula for your simple interest? So your amount will be your principal, be 1 plus RT. Sometimes you'll see your interest as your actual, you can use the distributive property. So sometimes they'll give you, if you look for simple interest, they'll give you this formula. This is your interest, depending on how many years. But we actually don't have to use this formula for this problem. The yearly interest is $500. How much is invested at each rate? Because they actually tell us how much we are going to be getting back. We don't need to calculate. Well, we need to be able to, because we also don't know how much is in each fund. We know that we invested a total of $12,000, but how much do we invest in the 5%? Might have been 12, and then 2,000 on the 3%. So let's go set up some variables. We have 2 unknowns. We don't know how much we invested in the 5%, and we have no idea how much we invested in the 3%. So we're going to label X is going to be the amount of money invested in the 5% fund. Now Y will be the amount of money invested in the 3%. Now I do need to be able to see your variables declared. So that is essential. And now let's get set up our equations. We know that the total amount is 12,000. So what will be my first equation? Correct. That'll be X plus Y should be equal to 12,000. Now, and ideally it should say that we invested it in 1 year. So therefore, your R is 1. That's your T is 1. So therefore, I need to be able to find out how much interest I'm getting back. I know that the amount of interest that I get back from this will be the X multiplied by 5%, which is a percentage will be 0.05. Correct? That's how much money you're going to get back from your 5% interest. How much money are you going to get back or from your of interest will be of 0.03 Y. And that is the interest for your 5%. This is the interest for your 3%, and in total will be 500. And now we can solve it. So this is a very typical problem. This problem will be on your test. So therefore, what should I do first? Correct. I should just cancel my decimals by multiplying by 100. So let me rewrite the first one, X plus Y equal to 12,000. My second one multiplied by 100 gives me 5X plus 3Y. Multiplied by 100, I just need to add 2 zeros. So now go ahead and solve it by combination or substitution, whichever you prefer, and see what you get. So in this case, I'm going to cancel, go and pause it if you haven't solved it. I'm going to cancel my, let's see, how much is invested in each rate? So I need to find X and Y. I'm going to cancel my y, so I'm going to multiply by negative 3, since that will be a smaller number. So therefore I have negative 3x minus 3y is equal to negative 36,000. The second equation will stay exactly the same. That gives me 2x is equal to 14,000. Divide by 2, so x equal to 7,000. So if we invested 7,000 in the 5%, and we invested a total of 12,000, what should be my value of y? Correct, that should be 5,000. Together will be 12. So let's just write that down. 7,000 is invested. In that's an x, so it'll be 5%. 5% fund. And 5,000. And let's try another word problem. Another typical word problem, I guess we'll see. Go ahead and copy it down or paste it, and then we can continue once you are ready. Go ahead and pause it. So now take the time to read through it and see if you can set up two equations. Remember that you want to set up your x variable and your y variable, since we're dealing with a system of equations. See if you can set up your two equations, and then we can check. Go ahead and pause it. So it says, you got it? The number of text messages sent per month varies by age. In a recent survey, the average of the number of texts sent by two age groups. So we have two age groups. The first one is from 18 to 24 years old, and those that are 25 and older. So the average was 2172. So let's go set up your x variable and your y variable. So your x is 18 to 24-year-old, and that's the number of text messages. So number, hashtag number of text by 18 to 24. And y will be the number of '55 and over. So those are your brothers, and that's your, well, your parents are younger than this, right? That's your grandparents. Now, how can I set up an equation? So it says in a recent survey, the average of the numbers of texts sent by two of the age groups. So I need to be able to find the average was 2172. So how do I find the average? Correct. So it'll be x plus y divided by 2. And that'll be equal to 2172. However, the number of texts sent by 18 to 24-year-olds exceeded the number of texts sent by 55 and over by 32. So I know that's going to be 3362. So what will be over here? So the number, who sent the most? The number of 18-year-olds is greater than exceeded by those. So you'll end up with x minus y. So if you subtract them, that should give you the ones by they exceeded, correct? And sometimes you just be careful with this equation is the one that people miss the most. And now I need to solve it for x or for y. Combination substitution. What should I do first? Go and solve it, pause it, and we can check our answer afterwards. So one of the first things I'm going to do, I'm going to go and multiply by 2 so I can cancel my denominators. Remember, we talked about that before. So therefore that gives me x plus y is equal to 4, 14 carry 1, 2, 3, and 4. And the second equation says the same. And now I can cancel. I want to do by combination since they're ready to cancel. So I can just cancel. That gives me 2x is equal to 6, 10, 7, 7. Divide by 2. So x is equal to 3853. That's x. So how can I find y? I can just plug it over here. So let's go and find y. So x is 3852, 53, minus y equal to 3362. So that gives me minus 3853. That gives me a negative number. Negative y equals, let me place my larger number over here. So therefore I'll be 3853 minus 3362. Subtract gives me 1. Subtract, borrow 1. So that's 7, that's 15, which is 9. That is 4. So I'll be negative 491. So therefore y is equal to 491. If I add them together, should give me a total of, well, that will give me a total, but I don't need to add them. So now we can just write our answers. So therefore 18 to 24 sent 3,853 messages or text messages. While 55 and over. 491. Now, if I add them together and divide by 2, then that should give me 2172, and it does. Right? So that will be the lesson for today. Have a great day, and I'll see you guys next time.